It's time to be able to save the progress we make in our quests, because you're not going to play an entire game with all the quests that have been made in one sitting, right? Or even if you are, you want to be able to save that stuff. So let's make a save system to save the progress we make in our quests. Now, essentially, we're going to need to keep track of two things for our save system. Number one is we already have our game instance with the current progress of all of our actively started quests. So we can just make a slight variation on this data type that's a little bit more save friendly. Because this at the moment, if we just get something and we split this structure up in, uses objects. And we can't save objects because these are places in memory, and whenever we load the game again in the future, these are going to be in a different place in memory. So we need to make a struct that saves the information that's also in this object, and then we also probably don't need to save the quest name and that kind of stuff. So we're going to be making a structure that is a little bit more friendly toward that. And then we also need to save all the quests that we have finished, because that's probably going to be relevant information to finish as well. So the very first thing is we're going to be adding a new array here of finished quests in our game instance, and that's going to be just a state tree object reference, and we'll make that into an array. And here, quite simply, we have our quest manager already for our state tree. When we finish a quest, we already remove it from our active quests in progress. We'll just simply also get our finished quests and add this quest to that. So what we'll do is we'll simply add. We can add unique to make sure that it doesn't add them twice, just to be sure. And we'll just put this in between here, and we'll promote this to a variable quest asset. Now, this is kind of annoying, and this is a thing that maybe if you're watching this in the future is possible to do, but state tree tasks don't seem to have a good way of getting the state tree assets that they're currently executing on. So we can't just get state tree or something like that. You can get states, but that's something else entirely. So you can't really do that too easily. So what we're going to do is we're just going to make that into a variable, expose it, and that way, if we go back into our quest, we can just go into the root here. We have our quest manager, and we can just say, hey, this is the quest that we're working with. It's annoying that we have to set it up this way. Hopefully in the future, if you're watching this and it's Unreal 5.17 or something, that'll be a feature that just states can request whatever state tree they're on. As of right now, that doesn't seem to be possible. So yeah, that's just going to add itself to the finished quests array on our game instance. And that's really all that we need to do on this side for the time being. So on the game instance, we're going to need to set up the saving and loading functions. So let's make a custom event for save game and a custom event for load game as well. We'll be filling those out both shortly. And I'm also going to add the onInitialize event, which is here somewhere surely, or just called init. Because when we initialize the game instance, what I want to do immediately is I want to just create a save game object, and for that we're going to need to make a save game class. So let's make one of those. New blueprint, save game, and we'll call this SG quest. We're going to leave that alone for a moment. We'll come back to that in literally a couple of seconds, but before I forget, we'll just put that save game quest class into the create save object, and we'll save that out as a variable on our game instance. So this will be our quest save object. Now, this is going to need to have a couple of things, so let's open it back up again. We are going to make a variable for all of the finished quests that we have done. So let's call that finished quest. And again, you might be wondering, how are we going to even do any of this? Because you can't save those assets either, because those assets are, again, going to be object references, and you can't save object references. But since they're assets, they're actually pretty easy to save. You can just save them as a string. And we're going to save them as an array, because of course there's going to be a bunch of them. But then, saving the current quests in progress, we can't just put that into a string. Well, we technically could, but you don't want to. So we're going to make a structure specifically for that as well, just like we did in the last video. Let's go into our blueprint here and make a structure, and we'll call that quests task status save. This is why we called the other one display, because this is going to be one that's very similar to it, but different in some important ways. This is going to be storing the quest ID, just like the other one as well, which is going to be a GUID. But then it's going to be storing an array of another structs that we still need to make as well. So let's go back in again and make a structure. And this one we will call task status save. And this is going to have inside of it the task ID, which nobody supplies is going to be a GUID as well. And then it's also going to have the task status, which is going to be a bool. We might expand this later on to also include like a float for the percentage of how far along you are in a certain task. If a task has like sub-steps, like collect X amount of a certain item or defeat X amount of enemies or whatever. For now, I'm going to keep this simple as it is. So we now have this task status save, so we can go back to our quest status save and add that in as a variable as well. So this will be the tasks, just tasks, that'll be good enough. And that'll be of type task status save. I'm going to make that an array because a quest is going to have multiple tasks that it needs to save out. With all that set up, we can go back into our save game blueprint here and make our quests in progress array, which is going to be of the type quest task status save. So now let's go ahead and populate both of these arrays. You can go back into your blueprint game instance and do that all from here. Personally, what I like to do is I like all the objects that need to like have their data saved in any way, shape or form. I like those to report themselves to the same game object, because that way you don't end up with like one massive, pretty hard-coded save game function in here. So let's go back to our quest tree here in a quest manager. If we open that up, we already have something where we're adding the quest assets to the finished quest array, which might be useful, might not be useful, depending on like what you want to do. But why not also use this exact same place in the code to add itself to the current save game object? It's nice to just have the save game object existing in memory so that we can do that. So let's get this game instance reference that we already made before and get the save game object that we just created. And from there, we can get the finished quests and just add to it. Just to be sure, though, do use the add unique, because there's no use in adding this multiple times. And just slot that in between there. For assets, it's very easy. We have this quest asset reference already, so we can just get object path as a string, and that lets us save references to assets in a save game, because we can use this string later on again to load that object from a string and get a reference to that asset again. You can't directly save assets because they're memory address pointers. So this way, whenever a quest finishes, it reports itself back to the save game object that it has finished. And that's kind of the way that we're going to do the individual tasks as well, but that's going to be a little bit more involved, a little bit more complicated, because it's going to need to update pre-existing parts of that array. Speaking of which, while we're still in the quest manager, when we add this information to the quest display, we also want to create this in our save game. But, and this is the kicker, we only want to do that if our quest doesn't already exist. Because if our quest already exists, we are just going to assume that our save game knows what's up. And this is where I kind of skipped over something last time, because we do want this other branch here of this for each loop to also hook up to this adding node. But there's going to be another adding node in between that it's not going to hook up to. So I made a little bit of a mistake here. Just hook it up now and pretend like I didn't make a mistake. So we'll get our quest game instance. We'll get the save game object. And from there, we'll get the progress. And to that, we will add, or add unique. In this case, it doesn't actually like matter that much. We'll split structure bin, and we just put in our quest ID. Much like the other one after it that we made before, we don't really need to give in the tasks themselves, because the tasks are going to populate that when they get added by the task manager. or by the task creation, depending on how you have things set up. For now, we just need to make sure that this array has an entry with this quest ID. This is where C++ would also be nice to work with, because in C++ we could set up a way to like find item based on only the quest ID instead of the entire struct. In our case, what we're going to need to do is we're going to need to loop over the entire thing and compare quest IDs, which is essentially the same. Quick little cut in here during the editing. You're going to see me using this quest progress in this for each loop. That is a mistake. What we need to do is we need to get the save game object and get the progress from there instead. So what we're going to do is we'll recombine this structure pin, disconnect this, connect this up, split structure pin, and you'll see the difference here. The array element tasks is going to be a dark blue for it being a struct instead of a light blue, which is for object references. So that's how you can see the difference between those. For the rest of this segment of the video, you're going to be seeing this as light blue, but that's because I used the wrong array here. So you don't want to use the quest progress immediately from the game instance itself. What you want to do is you want to get the save game object in there, and from there get the quest progress. However, you still want to use the normal quest progress array for adding the name and quest ID at the very end here. So let's go ahead and set that up. Go into our objective manager, and here all hell is going to break loose. I'll make a little bit extra room because we're going to definitely need that. Here, the very first thing that I want to make is a new function, something like task ID already in save progress. Very long name, very descriptive though. There's going to be taken in a task ID, which is going to obviously be a GUID. And then also is going to take in an array of our tasks, which is going to be the task status save. And that's going to be an array, as I just said. So we'll, for each loop over that, and then as per usual, what we do is we split the structure pin, and we are now going to compare this task ID to the task ID that we give in. And here we essentially just check, hey, this condition, does this array that we're given in, which is going to be taken from our save data, already contain this task? If it does, what we do is we return, and we're going to return with a couple of outputs. So we'll do a whether or not the ID was found, and that's going to be a single bool. And then we'll also return whether or not the task was finished. So let's add in our return node. And obviously, if we have found an ID, the ID is going to be set to true. And then whether or not it was finished is going to be the element array task status. Because it might have been, it might not have been. The only thing that we know is we found the ID and we're going to be returning whatever value was associated with that ID. If we complete the entire loop without finding anything, of course, that means that we didn't find this ID, so it doesn't yet exist. So in here, inside of our for each loop, after we bind to objective finished, we're going to check, hey, does this task ID already exist in our save game object? Yes or no? And we'll do that by getting our array element and getting the task ID that we set up way back in the first video. And then we'll have to put in an array, and the array that we're going to be putting in will be from our game instance, get save game object, get progress, and then we're going to get a reference, because we're going to be updating it in a moment, of a certain index. We'll get back to that in a moment, because we're going to be creating an event that actually keeps track of that index in a second. But from that, we'll break and get our tasks array that we can put into this function. If this ID was found, what we do is we get our object and we set our task finished. So set task finished just to whatever the task finished value was, because apparently it already existed, right? But if it wasn't found yet in that array, what we're going to do is we're going to be adding to that array our own task ID, which we get from here. You might need to make a little bit of room to keep this being somewhat readable. Split structure pin, of course, providing that task ID with the status of just nothing, because if you're just adding it, you probably haven't finished it before. I'm going to just take all this code that we have here and just pull it down a little bit so that it's a bit more like visually readable. We have a little bit more room to work with. So add in some things like some reroute nodes here. So we can reroute this and make it look a little bit better. And maybe move all of this over a tiny bit as well. Add in a reroute node here, reroute node there. Just like a little bit of visual cleanup to make it a bit more readable. Now, for all that to work, we do need to be able to get the index in our quest progress. And the reason that we need to make that into its own like separate little function to run and update is because this happens whenever we originally initialize these objectives with the objective manager, right? But if we finish a different quest and the order of that array gets updated, before we then go back at a later time and check this stuff again, the index might have changed. So anytime we need to get this index, we need to kind of like rerun that code. So the way that we do that is we make this into a function, get index for quest ID. And we're going to make this a blueprint pure node. That's going to make it one of those green nodes, and that's just going to run whenever it's called without it needing to have like execution pins. And what this is going to do is it's going to take pretty much this whole string. So this game instance, save object, quest progress, and it's going to for each loop over that. And to nobody's surprise, it's just going to compare all the quest IDs, which you do need to like split structure pin for that. It's going to compare all the quest IDs to the quest ID that we are working with for this specific quest. And when it finds that, it's going to return the index for it. So we set that to an integer and we simply return the array index. And that's also then going to stop the rest of the for each loop. So that's built in with the return node. And now we can just use that get index for quest ID and put that in there. And then one last thing here is after this for each loop with break, once this completes, I do want to check, hey, did we also just initialize this entire thing with all the tasks complete? Because that very well could be the case, because we are potentially setting like task finished here from our save data on all of the tasks that this thing is managing. So if we've done all of that, we want to say, hey, that actually kind of means that we should move on to whatever is next. So we do that at the very end here with a branch, and then we're going to just, when this is true, we're going to finish this task, and I'm going to set succeeded to being false, just in case we want to like reward somebody with a reward when they finish a part of a quest, like one of the states itself. We can do that now based on whether or not they succeeded or they failed. And this is going to still complete this state. And this is going to be a little bit of information that we're going to use on, hey, was it a successful completion? Meaning that, are we going to need to like give the reward or not? Which can be a nice way of doing things. So that is pretty much setting up all of the saving part of things. Again, these objects are going to report themselves to the save object. So the save object itself and the game instance itself doesn't really have to do anything on save game, aside from just save game to slots. It's going to take the save game object that we have here, and the slot name will be just quest for now. You can of course make an entire save system with like different slot names, but that's not really super relevant right now. I'm going to add a print string to this that just says saved for our own feedback purposes. Loading the game is going to be a tiny teeny bit more complicated, so let's get into that. So when we load game, first we want to check, does save game exist? We're going to check whether or not the quest save game exists, of course. And if it doesn't exist, we are not going to do anything because there's nothing going to be like there to load, obviously. But if it does exist, we will load game from slot. Game that we're going to be loading will be the quests, and we need to cast that to our save game for quests. After we've loaded that, we're just going to set our save game object variable that we have here to the newly loaded one. That means that the one that we created in the beginning here is going to eventually get garbage collected and deleted just for us, but we want this new one to be the one that we're going to be working with going forward. Then we're going to use this now to get our finished quests first. This is going to be fairly straightforward because what we do is we for each loop over that. And we're going to take every one of these strings and get the corresponding asset for them and add them back into our finished quest array. So the way we do that is we get the assets registry. And with the asset registry, we can get an asset by object path. Now, there's two of these. I'm going to go with using the top one. And you can just pull through this string into this name variable. And that will get you a struct for asset data. If you pull over this, you can just get the asset, cast it to a state tree. And now that it's a state tree, we can add it to our finished quests array. So get the finished quests, we add unique as per usual, put it in there, and this is now going to repopulate our finished quests. Now, there is an argument to be made that we do want to, at the very start here, maybe like clear this out so that it doesn't maintain quests that we might have been like completing on a previous save file. Well, this is pretty much everything there is to it, because everything else about saving this stuff we already did. Because of the objects reporting themselves to the existing save game object and also using the save game object to like pull data from, we don't need to like explicitly add any saving or loading for every one of those pieces of data because they're already integrated with the save game object that's currently in memory as the active one. So now with all of that set up, let's go into our third person character and add a couple of debug keys for all of this. Let's do debug key F and debug key like L for load maybe. And this is going to, in both cases, get the game instance, cast to our PP game instance. It's going to do this for both. So let's just copy this over real quick and hook all of that up. And in the case of L, it's going to load game. And in the case of F, it's going to save that game. Now, this doesn't quite work yet, because when we load the game, quests don't know that they need to activate. We'll have all the data for them to activate with, but we still need to like activate them. So what we do, go into the quest giver blueprint. So let's just open it right here. And there on begin play, what we'll do is we will get our third person character, cast to that with the get player character. And then the third person character itself is going to make a little bit more room in its code. So that's a little less crammed in here. When we load the game, I want to just send out an event dispatcher game loaded. Maybe save game loaded, whatever. And we're going to call that out whenever we load the game. That way, we first load the game, all of the data will be in the right place in the game instance, and after that it's going to call out to anything listening to this, which is going to be all the relevant quests, that a game, save game has been loaded. So we can then use that in here to assign to game loaded, where we can get the game instance, of course, cast that to our PP game instance. Again, this is probably why you want to make like a blueprint function library for this, because this gets tedious to do real quick. We get the current progress of everything, and we for each loop over that. And for this one, I'm again cutting in during the editing, because I'm getting the game instance here, casting, and then immediately getting quest progress. Of course, this quest progress is going to be set by the tasks within this quest, so this is going to be empty until the quest is started, and we're using this to see if the quest should start. So the issue here is we need to get the save game object and get the progress array from that one. It's a little confusing having both a quest progress of one type as just an array on the game instance, and having a slightly different type quest progress on the save object. So that's why I'm cutting in a couple of times during this video, because I also messed it up while I have a reference on my other monitor of how I set it up before. So if you get a little bit confused between the two of them, don't worry, it happens. Anyway, so you instead use this one, so you recombine this structure pin. If you need to refresh node to make it gray again, hook this one up into there, and then split structure pin again and get the ID from there. You'll also be able to note that aside from this one being sometimes light blue, you also shouldn't be getting any of the name stuff in anything that is supposed to save, or load from save, or write to save, because we're not saving those names to save files. That's entirely unnecessary to do. And we're going to be splitting that, trying to get the quest ID. But now we run into the issue again where we can't get the quest ID from our state tree inside of here, because you can set things in the state tree, like we can just go in here and we can like set these values. You can't get them though. Unlike behavior traits, whatever, where you can get like variables by name, state tree doesn't really like allow you to do that. So what we do instead is we just store the quest ID on the actor itself. So if I do quest ID here, that's going to be our GUID. Now, extra thing is that this way we can technically automate generating the GUID, which I'll do in a moment. So if we go back into our quest here, instead of having the quest ID existing on here, we can delete this in a moment. What we're going to be doing instead is we'll refer to our quest ID anytime we need it, which is going to be in this like objective manager. From our schema, set this to BP quest giver. Compile that real quick. And then the quest ID we can get from our actor quest ID instead. Same here, we can get that from actor quest ID. So we don't need to generate it anymore on the actual tree. So now that we have the quest ID on the actor, we can check against it on the actor for if it exists in our save data. And if it did exist in our save data of currently in progress quests, we, of course, start the quest. So now we set the quest GUID to being exposed, just so that we can set it easily from the editor here. So now you will note that we don't have any quests. I pick up this first quest. We see walk to location 2. We do one of them. It's marked as being completed now. I press the F key to save and restart the game. No quests are available. I press the L key to load. And now we can see that we almost are there. It doesn't quite set up the completion state of our objectives yet, but it does properly load in what quest existed in our list. And the only reason that happened is because we don't have the task IDs set up yet. So we just need to go through these and set up these task IDs so that they have a unique ID that the save system can take advantage of. And then in here in our objective manager, when we finish an objective, we also need to update that in our save data now, not just as part of the object itself. So what we do is we move this old task complete check away, because we're going to, for each loop with break, because why not, and hook this up with the completed pin. And we're going to need to be looping over effectively this exact same setup again. So we just pull this in down here. And this is going to get the corresponding ID for whatever is relevant at the time of execution here. So that's why we make this that pure node. And here we just break. And here we just check for every single one. And we'll check here if the task ID that we're looping over is the same as the task ID from the objective. So this is why very early on we make this objective reference part of this event dispatcher, because now you want to be able to check, hey, the thing that we just finished, we want to kind of fish that out of this array. And again, because we're not working with C++, we need to actually like iterate over entire arrays to do this. So once we have found the corresponding task ID, which realistically isn't going to be that much, by the way, because there's only going to be a couple of tasks in any given quest, what we'll do is we'll pull off of this again and get a reference, specifically, not a copy, a reference to whatever index we are on. And then we set variable by reference. Here we'll split the structure pin and we'll set this value to true. And then the task ID will of course just be either this task ID or this task ID. These are going to be the same because that's what this node is checking to begin with. And then once that is done, we can break the for each loop because we have found our match and updated it. So this will update your save file information as you complete objectives as well. So now you can see if we go through, we have no quests active. Now we have one quest active. Now we have a quest active with one objective solved. If I press the F key and I restart the game, you can see no quest again, but if I press the L key, we can pick up where we left off. So we now have a functional save system. Believe me, I know that this is confusing. There's a lot of things that are very much alike and that are easy to get like cross-wired. Like I said in another earlier cut-in in this video, even while having the reference that I made earlier this week open, I made a couple of mistakes of taking one array instead of the other, and it's entirely natural to make a couple of mistakes with all this stuff. But we effectively now have a quest save system, which is like quite important. So from here on, we can start expanding a little bit, and maybe we need to come back to this save system and tinker a little bit with it if we're going to expand it into having different types of tasks that might need to have different information that gets saved, but the same like things apply to it. Like every location that we've been here for like setting and getting from that save file, effectively all that we need to do at this point to add stuff to it is go into that blueprint struct, which I think it's like this one, right? And we can add stuff to this, and we can just like read and write from that in like the couple of different places that we're working with this. This is the downside of working with save files the way that I like to do, which is creating one that just exists in memory that you can access for writing or reading to, because it is a very decentralized way of working, so it is easy to get lost a little bit. But for some of the parts that we're doing here, it's really the only way to get the information from these states in the state tree into our save objects, because it's not information that can be requested, only information that can be given. So for the next part, I think we're going to do something a little bit lighter. We're going to just make a couple of different types of objectives. We at this point have only been like going from location to location. I want to show you how you can set up your own like custom actors that have their own like custom objectives that you can bind to instead. And a very big thank you to all my Patreons. You can see them on screen right now. If you want to help support the channel or get any of the project files in any of my tutorials, there's a link down below to the Patreon page to support me, or alternatively as a YouTube member. And of course, an extra massive thank you to my Cave Digger tier supporters, Mauricio Farias, and my Cave Student tier supporters, Oiku and Earl Monsville Urno.